Hello everyone. Today we are going to discuss about the topic elasticity. We are going to see about plasticity and elasticity. First, we are going to see elasticity. When an external force is applied on a body or a material, the material gets deformed in its shape or in its size. Now, when we remove the applied force, the material gains its original shape or size. This applied force, which is used to deform the material or a body, is known as deforming force, and this nature of the material is called as elasticity. And this material which shows the elasticity are called as elastic materials. Here I have mentioned some of the elastic materials. Then next week we are going to see about plasticity. It is the property of a material that when we apply some external force, obviously it changes its shape and size, but it does not comes to its original position. It deforms permanently after removal of the external force or deforming force. This nature of the material is known as plasticity, and the material which shows this plasticity nature is called plastic materials. Here I have given some examples for plastic materials. First one is wet clay, and second one is crushed water bottles. Here when we remove the apply of deforming force, it does not come back to its original position. And now we see some definitions related to elasticity. First, stress. Stress is defined as the restoring force per unit area. The restoring force is defined as it's the internal property of the material which shows the opposite action to the external force. The maximum stress of the material that can withstand is called as breaking stress. And here mathematically it is defined as stress is equal to force per area. Here F is force, and A is area. The unit of the force is Newton, and the unit of the area is meter squared. So obviously the unit of the stress is called Newton per meter squared, and we can also call it as Pascal. And here strain. When an external force is applied, that is deforming force, there's a change in its shape, length, and volume of the material or volume of the material. The ratio of the increase in its dimension, that is length, shape, or volume, to its original value is called strain. Here they have showed some change in increase in length. The dotted line shows that the increased length of the material. It is the ratio between two similar quantities, so that it has no units. Next we can see about Hooke's law. Hooke's law is defined as within the elastic limit, the stress is directly proportional to the strain. That is stress. Here the to eliminate the proportionality, we introduce some proportionality constant, that is E. E is given as modulus of elasticity, and it depends on the nature of the material. Here stress is equal to E into strain, and E is given as stress divided by strain, and its unit is Newton per meter square. Next we can see some modulus of elasticity. So it is classified as three types. The modulus of elasticity is classified as three types. First one is Young's modulus, second one is shear modulus, or we can call it as rigidity modulus. Third one is bulk modulus. First we can see about Young's modulus of elasticity. Young's modulus of elasticity is the ratio of longitudinal stress to longitudinal strain. Normally, the modulus of elasticity is called as stress divided by strain. Here, particularly, Young's modulus of elasticity is called the ratio of longitudinal stress to longitudinal strain. The longitudinal stress, or it is called as tensile stress. This is applied along the length, and hence it causes change in length. Linear strain is the ratio of change in length to its original length. Next one is rigidity modulus or shear modulus. It is given as the ratio of shearing stress to shearing strain. Shearing stress is applied tangentially to a surface, and as a result, one surface is displayed with respect to the another fixed surface. And third one is bulk modulus. It is the ratio of total normal stress per unit volume strain. Here in this picture, the force is given to the body along all sides. So here the application of normal stress causes change in its volume, and volume strain is the ratio of the change in its volume to the original volume. So these are the some basic informations regarding the elasticity topic. Thank you.